solving a system of linear equations by graphing. So a system of linear equations is a set of two or more linear equations that have the same solution. So remember, linear equations have two variables. So in this example of this system, notice that they both have the same exact variable. Okay, so in order for it to be a system of two equations, you need two variables that are exactly the same. Okay, and then remember, solutions to equations are numbers that satisfy the equation when you plug it in. So for example, the solutions to this system are x equals 1 and y equals 2. So notice I have two solutions for a system of equations with two equations. So the reason why these are both solutions are because if I plug in x and y in both of the equations, it'll make both sides equal the same thing. So for example, 2 times 2 equals 1 plus 3, so 4 equals 4, so it works for the first equation. And if I plug it in the second one, I get negative 2 plus 8 equals 6, so 6 equals 6, so it works for both. Okay, so the solution to that system would be 1, comma 2, right? And we write that as an ordered pair. Okay, so this is all referring to graphs when we're talking to a system of linear equations. So this is how you guys solve this. So you guys could use any method that you want to graph. I don't care if you use an XY chart or slope-intercept form. I think slope-intercept form will be the quickest and the easiest. So all you literally have to do is graph your two lines. So I'm going to graph this first line in green. It's already in slope-intercept form. Remember, this is my starting point, right? That's my y-intercept. So on the y-axis, I'm going to plot negative 3. Remember, we start on the y-axis, not the x. A lot of us forget that. Okay, and then you have to count your slope. So I'm going to go up 4, and then to the left 1 to keep it negative, right? Because it's negative 4 over 1 or 4 over negative 1. It's the same thing. So up 4, 1, 2, 3, 4, to the left 1. 1, 2, 3, 4, to the left 1. I could also do the opposite. 1, 2, 3, 4, down to the right 1. Make sure you're following all the way through in these graphs. Okay, it's super important not to have your nugget lines in these ones because, well, you'll see why in a second. So I'm going to graph this second line in purple. Okay, my starting point is negative 9. So I'm going to plot negative 9 on the y-axis. And I'm going to count my slope up 2 to the right 1. Up 2 to the right 1. Okay, so if you notice, when I graph these two lines, they meet at one exact point. Okay, where they intersect is the solution to your system. So I'm going to identify that point, that is 1, negative 7. Or the solution is x equals 1, y equals negative 7. Okay, that's literally it. So we are graphing. I prefer that you guys write it as an ordered pair, but if you wrote it as x equals 1, y equals negative 7, I would not care. Okay, so in number 2, I'm going to do the same thing. So I'm going to start with this first line in the light purple. So I'm going to start on the y-axis at negative 7. Right, my slope is positive 10 over 3. So I'm going to go up 10, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I'm going to go to the right 3. If I kept going, I would go way off the graph, so I'm just going to leave it at these 2 points, and I'm going to connect. Okay, then I'm going to graph my second one. Let's just use the green. Starting point is positive 2 on the y-axis, right? Here's my y-intercept. I'm going to go up 1 to the right 3. I'm actually just going to stop right there. I'm not going to go all the way through because I could already see my intersection point, which is at 3, 3. Okay, so my solution is 3, 3, or we could say it's x equals 3, y equals 3. So both of these points are on the line, right? So that means that they would satisfy both of the equations, which in part make them a solution to the system. we're going to skip number 4. Let's just do number 3 because it's very similar to the rest of them. Again, my starting point is positive 7. Let's see my slope. My slope is negative 2 over 1 or 2 over negative 1. So I could go down 2 to the right 1, down 2 to the right 1. And I'm going to keep going until I go all the way through the graph because I don't know where they're going to intersect. Okay, so make sure you're making points all the way through because you have no idea where the intersection point is going to be. Okay, so I'm going to connect all of these points. And then I'm going to graph my second line. Again, let's use the purple. My starting point is negative 3. Now I could go up 1 to the left 3, but that's taking me away from the other line. So I am going to count the other way because I want to plot my points towards the other line so I could see where they're going to intersect. So instead of going up 1 to the left 3, I'm going to go down 1 to the right 3. And then down 1 to the right 3. Shoot. Sorry, I messed up. I started at negative 5. Okay, so down 1 to the right 3, down 1 to the right 3. There's my intersection point. Okay, and that is at 6, negative 5. 6, negative 5. Again, remember that's x equals 6, y equals negative 5. Okay, so I'm going to skip 4 and 5. They are the same thing as the other ones. Literally graph your two lines. Wherever they cross, that's your x and that's your y. Okay, but number 6 is a little bit different because it's not in slope-intercept form. Okay, so unless you're using the xy chart, we need to make sure we put it in slope-intercept form, which means we are solving for y. So I'm going to solve for y over here. Okay, so let me just rewrite this. I am going to subtract 3x from both sides. And then I'm going to get 7y equals negative 3x plus 7. Remember, it's y equals mx plus b, so we want the x first. And then the number second. Okay, and then I'm going to divide every single thing by 7. So y equals negative 3/7 x plus 1. Okay, so there's my first line. Let me solve the second line first before I start graphing, okay? And I am going to do that down here. Okay, so I'm going to subtract both sides by 3x. So 7y equals negative 3x minus 35. Divide everything by 7. So my new equation is y equals negative 3/7 x minus 5. Okay, so I'm going to graph that one in green first. So my starting point is negative 5. My slope is negative 3 over 7. So I could go down 3 to the right 7. Or I could go up 3 to the left 7. Okay, and I'm going to do the same thing with my purple line. My starting point is positive 1. My slope is negative 3 over 7. So I could either go down 3 to the right 7, or I could go up 3 to the left 7. Hopefully right now you guys are noticing something. These are parallel lines. And the reason why I know that, I could actually tell before I even graph, is because these have the same exact slope. Remember, parallel lines equal the same slope. Okay, if you have this happen, if you have the same slope but different y-intercepts, okay, they're never going to intersect. Well, our solution is where your two lines intersect, right? So if they don't have an intersection point, then what do you think that means? Right? That's going to mean that there is no solution because there is no x and y that they both share. Okay, so if you notice right away that you're going to have parallel lines, also make sure that they have two different y-intercepts. You could go ahead and say right away, no solution, because they're never going to cross each other. Okay, and then this last one, number 7, again, I'm going to solve both of these for y. So I'm going to subtract by 2x. So 3y equals negative 2x plus 6. Divide everything by 3. So here's my first line. I'm going to do the same thing with the second line in light purple. Let me do that over here. I'm going to bring over the 18 instead of bringing over the x. Divide everything by negative 9. So I get, sorry, that's 2/3. Negative 2/3 x plus 2 equals y. Okay, if you wanted to, you could also put the y on the other side. It says the same thing. Hopefully you're noticing something kind of similar to the previous example, but see how they have the same slope? So these are parallel lines, but actually they also have the same y-intercept. So these are the same exact line. Right, so if I graph these, I'm going to get the same thing for both. So 2, down 2 to the right 3, down 2 to the right 3. Okay, and then if I graph the other line on top of that, we're just intersecting all the way through. Now this one has solutions, okay, because clearly they are intersecting. Hopefully you're noticing that they're intersecting the entire line, okay? So that means that our solution is infinitely many. That is because lines go on forever and ever and ever and ever. So these lines are literally intersecting with the same x's and y's forever and ever and ever. However, it cannot be all real numbers. That's because solutions are only points on these lines. Okay, so if I picked this point, what is this? -5, -5, these x's and y's would not be solutions because they don't lie on the lines. Okay, so not every single number works. That's why it cannot be all real numbers, and all we could definitively say is that it's going to be infinitely many solutions. Okay, and that's pretty much it for this first lesson. We're going to learn 2 more methods on how to solve a system of equations. This is the first one. Hopefully this answers enough of your questions and you follow along with the notes, but if you have any questions about this, please feel free to email me. I will be available during our class time and class time on Tuesday.